So we've had a look at the effect of weightings and field size, and the last thing I want to look at is the impact of wedges and what wedges do when we add them to a plan. Now, the beam arrangement that we've got here isn't something that we would typically use a wedge on, because we don't need it in this beam arrangement. So what we're going to do is change the beam arrangement to one where it's going to demonstrate quite nicely what a wedge is. So it's probably not something we would do clinically in terms of treating a patient with this beam arrangement, but what it does do is show us what a wedge does and the impact of changing angles on wedges. Okay, so we're going to, instead of having an amp post arrangement, we're going to have a left and a right arrangement. So let's start off by changing the fields and spinning them round. So first thing we're going to do is change that gantry to 90. So the post field now becomes a right field, and we're going to change that to 270 degrees, and so that becomes a left field. So we can change that, the name of them, by clicking down there. So let's do that, and then everything stays correct. I'm going to call that right, and I'm going to call this left. And I need to spin the collimators round to 90 degrees. Now I'll explain this in a moment, but if we just do this for the moment, and all will become clear shortly. Okay, so they're round to 90, and then I need to set my field size up to be around the PTV. So we'll do the same as we did last time and just make it 0.5 all the way around, and just for demonstration purposes as much as anything. So we're not going to kind of optimize the field size this time. I'm just wanting to have a look at what wedges do. So let's do it 0.5. So I'm going to fit that, and then we'll click on the other field and fit that and close, and then let's calculate that and see what that looks like. So the first calculation will probably look a little bit odd on yours as well, because we will probably have our weighting still left unevenly from the previous plan. So let's have a look at our field weighting, and let's just equalize them back to 50-50, because that's what we need for this one. And I'm just going to go to planning, and I'm going to change the point at which the plan's normalized to. So we're going to go plan normalization, and we're going to normalize the plan to this point here, this D max 10, and click OK. So what we can see now is, with equal dose through each beam, that if we look at our 95% isodose, we get this coming up in the middle here like this. Okay, so what we're going to do, just so it's a little bit clearer what's going on, let's get rid of some of these isodoses on the display, and what I want you to do is just have the 90, 95 and 100 displayed. Okay, so we can see here now that the general effect that we get is the high dose region, it kind of dips up in the middle and then comes back down again. So the reason for this is the shape of the patient here. Okay, so if I was to measure a couple of points to kind of emphasize it to you, all should become a little bit clearer. So if I measure from here to here, I can see that the distance is 19 centimeters. So this portion of beam is passing through 19 centimeters before it hits this midplane. And then this portion of the beam up here is passing through only 14 centimeters, so much less. And so we can see that there's more dose up here than there is down here. Okay, and that, as I say, is because of the shape of the patient here. So what we want to do is add some sort of modification to the beam to take into account that difference. And so what we can do is add a wedge into the field, and that will do it, as long as we put the wedge in the right direction. Okay, so the easiest way I think to think about of a wedge is an arrow, and the direction of the arrow is the direction that it's going to push the dose in. So we're wanting the dose to be pushed from here down here. So if we thought of an arrow, it would be pointing with the point pointing in this direction here towards the ant. And if we think of the a wedge, then pointing, then we'd have the thick end there and the thin end there. So again, pointing down, and that kind of fits with filling this gap in here. Okay, so let's add a wedge and see what that looks like. So wedges are in properties. Okay, so we go right click, properties, and it's classed as an accessory. And this is where, when I mentioned about changing our collimator to 90, this is why we needed to do it to 90 degrees. So on a varying machine, the wedge is controlled, the direction of the wedge is controlled by the collimators and the direction of the Y jaw, so which way the Y jaw is moving, and it creates a wedge using an EDW. Like it's an electronic dynamic wedge. And so we need to have the Y jaws in the direction of ant to post, and to do that, that's why we have 90 degrees. Now you wouldn't know that other than knowledge of the planning system. So by selecting 90, the wedge is going to be either ant to post or post to ant, and this is where this out and in comes in. Okay, so if we select in, and okay, so one other problem with the Varian is the biggest field size we can have is 10 centimeters, and we've just got a tiny bit more than 10. So let's just change that to 10. So yours may or may not do that. If it does, then we need to change the field size. So let's go back to our accessory, and then we're going to click apply, and you can see now that the wedge is thick end here and thin end there. So that's in the wrong direction. Okay, so what I want to do is actually have an out wedge. So by changing it from in to out, it flips it by 180 degrees. Okay, so we'll have a chat about this properly in class at the end of the session. So I do want you to understand the differences between Varian wedges and Electa wedges, because they are, and Siemens as well, because they are quite different. So I've got a 10-degree wedge there on my right field, and then on my left field I'm going to do the same. So let's have a 10-degree wedge. So the other side was out, so I know this side needs to be in. Okay, so I've now got these arrows pointing in the right direction. So wedge is in the right direction, filling, if we thought this the other way around, it would be filling this area in here. So let's calculate that and see what impact that has. So we can see it's starting to push the dose down. And as I said, it's quite an iterative process, so there's no way of really knowing the answer without setting an angle and then changing it to see what effect it has. So I'm just going to go to the other extreme just to show you the other extreme. So if I go to 60 degrees on each, so 60 and 60, and calculate, let's see what effect that has. So we know that using a 10-degree wedge, it doesn't have a big enough effect because we still have that dumbbell shape. If I use a 60-degree wedge, we can see that it's now had the opposite effect. So it's dipping in at this side on the anterior. So the correct wedge is somewhere in between 10 and 60. Okay, so all I want you to do is go to your plan and adjust the wedge angle till you've got an optimum wedge. Okay, so and see if you can get it so it's nice and as square as possible all the way around the patient. And once you've managed to do that, we're going to leave it there for the moment for the planning. So I hope you've enjoyed those sessions, and you've now got a bit better understanding of what the impact of field size is, weightings, wedges, and a little bit better understanding of concepts such as Dmax as well.